Farmer Ted has chickens and cows on his farm. There are 130 animals altogether and 340 legs. We want to know how many cows there are. Well, that's a pretty good question for a linear system of equations. Here's what we do. First of all, we know we can't use C to represent chickens and cows. So just to eliminate the confusion, we'll let K be the number of chickens because there's a K in chicken. We'll let W be the number of cows because there's a W in cows. So the first equation, relatively straightforward, is K plus W equals 130. Now, we're hoping that every chicken has 2 legs and we're hoping that every cow has 4 legs. And if that's the case, then 2 times the number of chickens plus 4 times the number of cows is going to give us 340 legs total. So to summarize, we have 2 equations, K plus W equals 130 and 2K plus 4W equals 340. We're going to rearrange equation 1 and try to use some substitution here. I'm going to solve for W by subtracting K from each side, and I get W equals W equals 130 minus K. What I can then do is substitute that into equation 2. Equation 2 read 2K plus 4W equals 340. Well, I substitute the expression 130 minus K in for W. I can then distribute the 4 into the bracket, and I get 2K plus 520 minus 4K equals 340. And what I can then do is try to isolate the K term. What I end up with is negative 2K equaling negative 180. Well, I can then divide each side by the coefficient of K, which is negative 2, and I get K equaling 90. Now, a while ago, we knew that from the bottom of the previous page, we knew that W equaled 130 minus K. Well, we just figured out that K equals 90. So W must be 130 minus 90, which means W is 40. Which means that there are 40 cows, and they all move very slowly.